Hi, and welcome back to another episode in the C# Practical Funkiness series. Today we're taking a look at the option of T monad. If you haven't already watched the episodes, getting hands-on with bind and getting hands-on with match and a result type, I recommend reviewing those first. They'll give you a solid foundation. When working with a monad, simplistically, a kind of container that provides a bind method, you'll usually also find map and match, and to be honest, without these, the monad would be pretty useless unless you're exposed to its internals content, which you generally don't want to do. I've already covered what map, match and bind do, and their role in option of T is no different from how they function in other monads. So here I'll focus on some commonly added methods that are specific to the option types, either built in or provided via extension methods. So what is the option type, sometimes called maybe? It's a way to represent optional values without resorting to null. It clearly expresses intent, either a value is present, some, or it's not, none. This helps eliminate an entire class of bugs caused by null reference exceptions, and it makes your code more expressive and safer. Let's take a quick look at the structure of this implementation. We're using a read-only record struct to define our option of T. This modern approach gives us immutability and value semantics, which are perfect for functional style programming. Records provide built-in value equality, and by using a struct, we not only avoid heap allocations, but also ensure that the option instance itself can never be null. I've named the static creation methods some and none, following convention from other functional languages. These names clearly express intent and make it obvious whether you're constructing an option that holds a value or not. In this implementation, the presence of a value, the sum case, is held in the private value field, while the absence of a value is indicated by a flag internally, with the none type serving only as a marker to clearly express intent when constructing an empty option. It's never actually stored. Now a bit of background on how this design came about. I wanted to upgrade my previous option implementation, which used abstract classes, to use a struct. Why? Because structs can't be null, which aligns perfectly with what an option is supposed to represent. I also wanted to include an option type in my NuGet package flow, which already includes a result type, so I needed a redesign and some additional insights before making that change. Although I called my version potential of T, what you can see here is about 95% the same. The version going into flow just includes a couple of extras to handle serialization and deserialization when using gRPC or JSON. Personally, I find option types are best suited for optional properties, though they can also be used for return types. In my experience, I use a result type for return values 95% of the time and only occasionally use option there. But when it comes to modeling optional data, like maybe a middle name or an optional config value, the option really shines. Of course, you're free to design your own option type to suit your own needs, but I want to quickly explain what I did and why, as it might help you think through how you'd like yours to behave. Since an option should not be able to contain null, I throw an exception if you try to create one using the constructor with a null value. Most agree this is reasonable. On the other hand, if you assign a null using the implicit operator, no exception is thrown. Instead, you simply get an option with no value, the none case. This gives you both safety and flexibility. The match method allows you to handle both cases by providing two functions, one for when there's no value, none, and one for when there is, some. If you want those functions to return null, you can. The option type won't stop you or throw an exception. You're in control. Then there's the getValueOr method. sometimes called getValue or default in other libraries. It retrieves the value if present, or uses the fallback you provide if not. If you pass in a null as the fallback and the option is empty, it'll return null. Again, this is deliberate. I find this flexibility useful, especially when working with complex types where default values or null object patterns aren't practical. Alright, with the null handling details out of the way, let's move on to two additional extension methods before jumping into the demo code. Spoiler alert, while and then and or else are common functional programming methods, in this implementation the overloaded and then method is really just a wrapper around the map and bind methods. I chose to keep the core functional method names like map and bind so you can use whichever name feels more natural to you. And then is used when the option has a value and you want to transform it or chain another operation. It's essentially a more expressive name for map and bind. The provided function only runs in the sum case. On the flip side, or else is used when the option has no value. It lets you provide a fallback, either a default value or another option entirely. Together, and then and or else give you a fluent, expressive way to compose logic while maintaining both safety and clarity. On screen now is the type used for none. It's basically what is termed a unit. It doesn't have any meaningful value. For the demo, I've created a very simple user preferences object. It contains a few optional complex type properties, for example theme settings and contact methods, and those complex types themselves contain optional values. There's nothing overly complex here, but it's a realistic and practical setup. In places where we might have used nullable types or defaulted to null, I've instead used an option of t-type to represent the presence of or absence of a value in a much more explicit and safer way. Let's now look at the demo code, starting with the supporting methods first, just so we know where everything is coming from before we start chaining things together. The getUserPreferences and getUpdatedUserPreferences methods are there to simulate retrieving or constructing the user preferences object from a database or some external source. These methods return the object with some of the option properties populated and some left empty, just like you would have with real-world data. Then we've got getPreferredEmail, which I included to demonstrate that option of t works perfectly fine as a return type from a method, even though it's pulling data from within the user preferences object. The important point is that this method returns an option, keeping things explicit and composable. getDefaultThemeSettings is a simple helper method that returns a fallback theme settings object, just in case the user hasn't set their preferred theme. And lastly, sendEmail is just a stand-in for some real-world action. It gets called if and only if the email option has a value. Alright, with all of that in place, let's move on to the core of the demo code. The point of the demo is to show how the option type handles both missing and present values safely and expressively. The console write-line statements display output using both the user preferences and updated preferences objects, demonstrating how the code behaves whether optional values are set or not. At first glance, these examples might seem a little underwhelming, but the real value of the option becomes clear when you consider how you'd handle these same scenarios without it. Without the option type, you'd likely fall back to using nullable reference types and manual null checks, and depending on the depth of the object graph, that can get really messy fast. Let's take a look at line 18 as an example. Here we want to retrieve the user's preferred accent colour. If that's not set, we fall back to a default theme and from that try to get an accent colour. If that is also missing, we just use green as a final fallback. With traditional null handling, this logic would require multiple null checks. Without them, you risk a null exception during assignment. But with the option type, we compose the logic fluently and safely, without the need for if statements or null coalescing chains. So what is the option doing? The or else checks if the theme is present. If not, it calls the getDefaultThemeSettings method, and then safely traverses into the accent colour option, but only if a theme settings object exists. Finally, getValueOr unwraps the final result, giving us either the actual colour or falling back to green with no risk of a null exception. It's a clean, readable and robust way to express this kind of optional logic. Before you dismiss option as unnecessary, ask yourself how many null checks are scattered throughout your code base, and perhaps more importantly, how many might be missing. Anyway, we then print out the results on line 20. Lines 22 and 24 repeat what we've just done, but this time using the updated preferences object with no change to the option chain. The scenario for code on line 26 is similar, this time using the and then extension. Here we want to retrieve the user's email address if it's present. First we call and then on the contact methods property, which will only attempt to access the optional email property if contact methods actually contains a value. If contact methods is none, the chain short circuits and the fallback logic in getValueOr is triggered. But if both contact methods and email are present, we get the actual email address. Once again, this logic is concise, readable and safe, and we've avoided the need for nested null checks or guard clauses. On lines 30 and 36, we use the match method, not to retrieve a value, but to conditionally perform an action based on whether a value exists. In this case, we check if the user has provided contact methods. If so, we check whether an email address is available, and if it is, we call send email. This is a classic example of how match allows you to express conditional logic cleanly and explicitly. No null checks, no guesswork. Each match clearly defines what happens when the value is missing and what happens when it's present. It's functional, expressive and avoids the noise of defensive programming. Okay, we best run the code and see what we get. No null exceptions, so we did something right. All is expected with just the single email reportedly being sent, as we had this email address in the updated user's preferences. I think that about does it for today. I'm going to continue with the option type in the next episode, just to show you two more commonly used methods that you may come across when using an option type and or that you may wish to add to your own. I hope you found something of interest in this video, and as always feel free to leave good or bad comments and I'll do my best to answer any questions raised. If you found this episode or the source code helpful, please consider liking and subscribing to help support the channel. Thanks for watching. Until next time, bye for now.